review of the product safety issue, and I asked Bob, just to begin. Bob, may you introduce yourself a little bit?
Good afternoon, and thank you for inviting TC65 here. My name is Bob Kretschmann. I am the chairman of SC65A, and also convener for SC65B WG7, the PLC committee. I'll be talking to you about what I'll call traditional safety today, as opposed to functional safety. So this is safety of products that has to do with electrical, mechanical, fire, heat, that sort of thing. Okay, so the first thing, if you have any questions while I'm talking, please hold up your hand and yell out. That's perfectly all right. Actually, the more you do that, the less you hear me speak, and that's a plus also. Okay, so let's go, and we'll use this new technology. So forward. A new work item was proposed in December of 2009, and this proposal was that in TC65 we create a common safety standard for all the products within the scope of TC65. And as I said a second ago, this is the physical safety, electrical, fire, shock, and mechanical. So what I'll talk about today is, well, what was proposed, and what are we doing, and just where are we? I think this slide is very important because one of the other presenters this morning used this very same picture of an industrial plant. So if nothing else, in the standardization activities, it's important to note that our marketing departments are very standardized. You know, they're using the same picture. So this is what a plant looks like today. If we think about an industrial plant of 20 years ago, it might look something like this, but it didn't have all of the connections that are noted here. Now we have batching, blending, processing, we have packaging, material handling, shipping, and all of this is connected together with networks that we talk about feeding up to the corporate headquarters so that their MES computers, et cetera, can watch what's going on and pass that information on to suppliers and their OEMs and other plants. This is very different than things were 20 years ago, but it's getting more and more tied together. And this is part of the reason why the safety of the plant is so important. All these different systems are connected together. So if we look at that same plant, we look at each of the sections and we see all these different products that are used in different sections of the plant, or they may be the same products used in multiple sections. So we have transmitters and instruments used in the blending and the processing area. We have tracking software and hardware used in this area over here. We have EOI, PLCs, we have HMIs, PCS systems, and all of this is connected together. How do you make a system electrically safe in that kind of a condition? And that's what we want to talk about here. So here we see many of the different kinds of equipments that are all interfaced together over some sort of networks. They're physically connected together, they're in the same cabinets, et cetera, and they all have to be safe. So we see this closer cooperation in all these different industrial products, and then recently China approached the IEC and said, as they look at the products and try to apply the standards to the industry within China, they see a very complex situation because there's so many different standards. What do they do? How do they train people such that they understand the safety that's necessary? We also see that there are a lot of other product committees. TC65 products are used with TC17 products, which are sensors, TC22 drive systems, machinery. All this is integrated together, as we saw in the previous pictures. So we need to apply safety technology to all these different industrial products in a very efficient manner. We need to provide that so that the customers and people designing equipment and putting it together know how to interface these things correctly. And we need to provide, very importantly, agencies. Most of this equipment is somehow certified to some kind of standard. It might be some UL standard in the US, it might be a CSA standard in Canada, TCC standard in China, probably there's Korean standards, which I don't remember the names offhand, but all around the world there are different standards, and all this equipment has to be certified to these standards, so the agencies need to know how to do this in a consistent fashion. Time and time again, we see that if we don't have a consistent standard, then if you try to get your equipment certified in one country, the standard is applied in one way. You go to another country, it's applied in a different way. And you have conflicting requirements when you look at these different standards and how people approach them. So what we need is one standard for the entire market. Single standard, we decided that it would be a good idea to leverage the visibility of 61010. That covers a large variety of electrical equipment already, and it's very similar to the standards that we already use within TC65, and there's some history of cooperation between these two technical committees. This would then provide a clear source of requirements to the users and provide support for that work. One of the difficulties, you heard Roland talk about a call for help. If you want to work on standards, you're more than welcome. It's always difficult to get people to work on standards and keep standards up to date. So if we have more committees, more manpower working on it, then we provide a better standard because we have a better set of experts to draw from worldwide. So we'll utilize those TCs very effectively. We'll place the work where the expertise is available. TC66, you'll see in a minute, doesn't exactly have the right kind of expertise for industrial products. TC65 has that expertise. There's some disadvantages. You know, there's some effort. Nobody likes any effort. I'd rather not do anything. I'm kind of a lazy guy myself. And there's some level of market upset because there are some standards already in place and we would be shifting to a new standard. So that's always a little bit of a headache. So what we decided to do was to combine the safety expertise available in TC65 and 66. We then formed a joint working group, which is called Joint Working Group 13, which is under TC65 and 66, and we'll work together. So we talked about the standard. We'll take a look at how 61010 is organized today. And basically, it's sort of a tree. There's a generic base standard, and then there's three branches: medical equipment, laboratory equipment, and laboratory handheld equipment. And then there's a bunch of subparts you see on each of those branches. And as you might notice, it doesn't sound very industrial. And this goes to the point I made before that really TC66 expertise is not in the industrial area, but they do have good expertise in the area of safety. And some of these instruments are used in factories. So what we decided is, you know, there's some level of coordination there. Go to the next one. What would be good is if we could add another branch to the tree. So if we could add an industrial equipment branch, and then we have some proposed standards that would be there for different types of equipment. Now we have the same base standard, so we can leverage our expertise there to make that more broad and consistent. And then we can have the branches as we had before. So TC66 will handle exclusively the same branches that they handled before: laboratory equipment, medical laboratory equipment, and handheld laboratory equipment. That's where their main expertise is, and they'll continue to function in that area. Then on this new branch that we've added, which is industrial equipment, this is where TC65 will bring our expertise to bear. These are the kinds of equipments that are within the scope of TC65. This is what we know about, it's what we do well. So we'll provide the expertise in this area, we'll support those changes and the work in that area, and we'll provide the interconnectedness, because again, these are sort of standalone equipment, generally laboratory equipment. But industrial equipment, as we saw on the previous slides, it has a lot of other equipment that's attached together. Drive systems, positioning systems, sensor systems, all those things have to be networked together. They're in the same cabinets, they're built together as systems that way, and that's why it's important that we organize those together within the industrial environment. Additionally then, the base of the trunk of the tree will need some adjustments also. And as we've gone along and developed this standard, what we've seen is changes that are necessary in the base standard. And what's been happening is, as we see differences and changes, those are being fed back to the base standard, and there's some adjustments being made to the base standard to better cover industrial products. So if we look at this in sort of a future view, we have these as the standards that are in place today, and they'll probably add more along those lines. And right now we are working on this standard here, the 61010-2-201 control systems. Some examples of control systems are PLCs, VCSs, and programmable automation controllers. There are some other proposed areas. These are not, no work has started here yet. If there's good reason to provide these are just some ideas of equipments that are not necessarily well covered in the safety area. And when we started this, we made some guesses, so to speak, as to what might be necessary. So we could view those as possibilities for new standard work as time goes ahead. Some of those are standalone power supplies, actuators where movement's contained, actuators where movement's not contained. These are rotational linear slides and tables, human-machine interfaces, instruments, RFID systems, etc. So to look at this in a little bit different way, we have the 61010-1 as the basis. We have all of the existing TC65 work from laboratory equipment, and then we add new blocks having to do with control equipment, standalone communication, RFID, etc. These possibilities that I talked about. Okay. So the result of all this that we hope is that we'll have one standard. We'll leverage the recognition of 61010. We'll minimize the market upsets, so products can choose to migrate, but we expect there'll be minimum migration. Some things will have to change. As I said before, there is a standard already that provides electrical safety for PLCs, and that will have to migrate. We'll combine the efforts of TC65 and 66 into this joint working group. And we have the utilization of these two strong groups that we can utilize that capability very effectively and efficiently. We also provide some clean lines of impacts for the two TCs. There's been some level of crisscrossing, which we've talked about in some of the meetings. And this way there's some clean lines between the two groups of where we each work. And very importantly, there's good provision for support in the future. And that's most important because as standards go forward, they need adjustments, changes occur in the technologies, etc. And if you don't have the right set of experts, it's very difficult to maintain a standard. It easily gets out of sync with where technology is, and that's not a good situation at all. So what do we have as we stand right now? We've formed the Joint Working Group 13. We have 30 experts. 27 are officially listed from 8 different countries, as shown here. We have liaisons established, and we've had a set of meetings. We've had 4 meetings since the last plenary meeting in Geneva. This is the state of work right now on the first standard, which I talked about, control equipment. At the present time, we just recently turned into Bernard the CDB version, which is being translated into French at this point, and we expect we'll have a meeting later in the year to review that and respond to National Committee comments. Needless to say, it's a very complex standard. I said before about the expertise and the need for that. It's very interesting. It's based on 61010. So as we look at 61010 and look at some of the complex tables in there, we find out that we didn't actually know where any of those tables came from, and it was puzzling where the numbers came from and the dielectric withstands, et cetera, so it was necessary to dig back into history and find the people that understood those tables and how they were developed, and then make the appropriate changes and extensions that were necessary. So this is why it's very important to have good experts and have that history and continuity, and be able to draw on a wider set of experts who understand these very sometimes esoteric characteristics that are necessary in products as they're developed. So we talked about the interconnectedness, we talked about the connections to other TCs, and we need that closer relationship amongst all the standards. It also points to a higher need of coordination. Within TC65, we have to coordinate amongst our own standards. So before we have TC22, 44, TC17, all of these different TCs together, they are what form the basis of industrial automation systems. So if we think back to that picture that I pointed out before and we look at that factory, all of these different TCs contribute equipment that in an automation system in today's world, all of this stuff is connected together. So with that, we thought, well, another advantage would be to take advantage of the IEC TC65 schema. And the reason for this that we thought is that this is a schema which allows companies to develop equipments, have them certified in a consistent fashion, and then allow those certifications to be used worldwide. That's the intent. Companies don't like the idea, and it's very time-consuming and not very efficient, that you go to one place and you have it certified, and you go someplace else and you have some completely other crazy certification or sort of personal requirements. But in the IEC TC65 schema, the idea is the standards are unified. You can go to one place, you can get your certification, and then that certification will be recognized across the world. So you can have something certified here in Korea or in China or Canada or Germany, and it will be accepted in other countries worldwide. But when we looked at that, what we saw is that if we looked at those very same standards, you can see these numbers over here, it isn't very well coordinated. There's a CB schema for measurement equipment, and you see 61010 is here and 61131. And then there are power equipments, and some 6947 is a 17B standard. It's in this area. And then there's some drive standards. They're not anywhere. So the thought is that even in the CB schema, it would be a good idea to organize the standards that deal with industrial equipments together, such that then any agencies that deal with those standards would have a consistent viewpoint, rather than, in the case here of measuring equipment, you have a viewpoint that could have to do with PLCs, could have to do with laboratory equipment, and I forgot offhand what these other standards were. But in the power equipment, okay, this 947 is an industrial standard. These other standards have to do with household circuit breakers and that sort of thing. Well, how consistent can you be if you're a certifying agency and you're thinking about a household circuit breaker, and then you're thinking about how to do some factory floor sensor or a drive system? You're not really going to be very good at that. You're just going to have a haphazard view. So we sent a letter to Pierre de Rubelot in December of 2008, and we asked that we create an industrial automation category within the CB schema. That was just formed, and so these are the, sorry for the very small print here and the tiny pictures, but you know, if that was my picture up there, I would want it as small as possible, so maybe that's okay. So what was just created then is the CB Industrial Automation, INDAT. And the idea then is that these standards that have to do with industrial automation equipment then would be placed underneath that overall CB schema. And now we have a situation where we hope the idea would be that those agencies that focus on that would have a consistent viewpoint of industrial equipment rather than a mishmash of different kinds of equipment. So, what did we gain, or we hope to gain out of all of this? We need to recognize that we have this market is requiring very close cooperation between all these industrial products. We have a great interconnectedness of all these products because they work together as systems. They don't work by themselves anymore. We have a relationship of all the industrial safety standards. We're going to leverage the recognition of IEC 61010. We want to minimize the market upset and enhance the marketability of the products, provide one standard into the market, utilize the expertise of two very strong technical committees. We'll also utilize the IEC CB schema, and we'll provide some consistent viewpoint for the agencies that are certifying products. And in that way, we'll enhance our customers' experience and understanding of industrial safety and how to build those products and utilize those products in the marketplace. And I think you're rid of me. Thank you very much.